On this episode of Ask the Masters, we're talking Shotcrete with Shotcrete expert, Master Bill Drakeley and Grant Smith. They'll discuss the proper Shotcrete protocols in pools and much, much more. Enjoy this episode of Ask the Masters. This episode is sponsored by Informa Markets. You do not want to miss the next lifestyle event with Ask the Masters on February 27th and 28th. We are being hosted by Bazaza Tile, Shotcrete, and Wet Edge, and we're going to get dirty. We're actually going to install paper-faced Bazaza Tile with the backdrop of Shotcrete, all at the Wet Edge facility. Enjoy.
Hi, I'm Grant Smith with Alkalink Pools and Spas. I'm here with Bill Drakeley from Drakeley Pool Company, and we're going to talk about Shotcrete. Bill, nice to have you here.
Thanks. Nice to be here.
Great. One of the things that let's start out with, I think Shotcrete is a great application. I'm also a masonry contractor, landscape contractor, so we pour a lot of concrete, footers, cast in place walls. Obviously, all our pools are Shotcrete here in Southern California. It's cast in place is not a big thing. So I'm a huge Shotcrete fan. Can you kind of talk about the basics of Shotcrete and how it's applied and
Sure.
Best practices for it?
Well, Shotcrete is it's an action. It's a verb. It's not a. You can't hold it in your hand. So it's the it's the ability to spray concrete. Shotcrete is shooting concrete. Gunite, which is a trade name back in the day, is gunning concrete. So it's the basics of the process are you're spraying concrete at high velocity with good impact characteristics, good consolidation characteristics, and good density characteristics. So you spray this fluid concrete mixture and you get it to stand up based on its compaction, its density, and you can carve it and shape it any way you want based on the forms. It's an ideal way to place concrete because of the vehicle it's used to being placed, compressed air.
Right.
So it's like a fire hose. You're spraying this concrete at high velocity. You put it anywhere you want, make any shape you want. Good density, good durability based off of the compaction ability. So, basic concrete mix design for a swimming pool, minimum compressive value is 4,000 PSI. And you really have to try your best to screw it up, not to get 4,000 PSI. I mean, you have to screw just about everything up all at the same time to get less than that.
All right.
Screw up mix design, screw up application, rebound, that kind of fun stuff. So your compressive values are 5,000-6,000 PSI, and it's a terrific process to accomplish what we're trying to do and hold water and people swim.
Now, one of the big things I run into here is when we bid projects or we get a specification from an architect or just a general contractor is, they're all going to wet mix over here in Southern California and throughout the country because they have a perceived notion that dry mix is not very good. And I do tell them that, hey, look, you can screw both of them up and you can make both of them good. So kind of tell the difference between the dry mix and the wet mix.
Well, they're a screwdriver and a wrench. It's the different means and methods of placing essentially the same product. The end result, let's just skip to the end. The end result is dry mix shot, wet mix shot. Should have the same durability, the same compressive value, the same performance characteristics. It does not matter which process you use. You should have the same results, and both should be excellent.
Right.
Dry mix, you have more control by hand. You're mixing either on site or a volumetric mixer, and you're adding hydration at the nozzle, and you're spraying at a high velocity. Wet mix, you get it dropped off, or you mix it by bags in a paddle mixer and dump it into a hopper and pump it, and your vehicle still air, but the air is added at the nozzle and not hydration. Hydration is added at the plant or at your paddle mixer. So you're getting a fluid concrete placement. Just one is right at the substrate and one is at a truck.
Right.
But your vehicle's compressed air. Your nozzling techniques are the same. Your performance, your appearance, the durability, they all should be the same. We did an article, I think 2 years ago with Rebecca at Pool and Spa News. And she goes, Bill, you're the pool concrete expert. What do you like better? And I said, I don't have a preference. If you do them both right, they're both the same. Now, in a lab, you can get stronger compressive values with dry than you can wet. And the reason I say that is you need water of convenience for pumpability in wet. In dry, you just need the minimal amount to hydrate your Portland particles to have it start the hydration process and strength gain. So in a lab, you can get stronger with dry if you wanted to.
Right.
And dry has been around longer. I mean, the turn of the century, the inventor, Akeley, shot the Chicago Museum of Museum of Art or Natural Museum of History or something like that, and he coated the outside of the building with it. And he did all the different types of sculptures. So dry's been around for a long time. And they've used dry in Europe for tunnels and mining and railroads and infrastructure,
Right.
over 100 years.
Yeah. The one thing I miss about doing dry, because we don't do a lot of it here, is you can start, stop. When you get into really minute, different details on a pool, especially with some of the complex projects we build, with the wet mix, you have a time limit unless you put a retarder in it. So that's the nice thing about the dry mix was we can kind of start and stop. And
well, the differences are a couple of differences in dry and wet. So dry, you can start and stop because you're not hydrating your particles. Your dry mix goes into your gun and goes into your cylinders or your end gun and just gets pushed through air, still in a dry state, a little bit of moisture, up to 5% moisture, but not fully hydrated. So you have the ability to say, oh, okay, I got a problem with my forming or a pipe broke or whatever. You can start, shut it down, and work on it for however long you want, and then recharge and start again. And whereas wet, you have a time frame, even with retarder. Even with something that's going to block the hydration and the strength gain and heat generating process in wet, you still have a time frame, and nobody wants to send a truck back.
Right.
Or nobody wants to, it's tough to schedule that type of stuff. So, bigger volume in wet.
Yeah.
So dry, you do dental moldings, a little more intricate, and you're not pushing up as much. The hoses and it's heavy. It's easier on the guys. Wet mix is heavier, but you're pumping volume.
All right. Now, just say I run into this here where we have like a dry mix, shell that was done years ago. We're adding a spa, or there's a misconception that you cannot shoot wet onto dry or vice versa. But it doesn't matter because it's all shotcrete. Yeah, it's all the process.
Well, the process is you're driving. So let's talk about cold joints. You're
right.
referring to a cold joint.
Yeah, correct.
So the American Concrete Institute defines a cold joint as a lack of commingling of different concrete pours or materials. So I pour a sidewalk down the road and I stop at the end of the day. Next day I want to pour up against where I stopped. That's a cold joint because the fluid concrete is not going to penetrate the hardened concrete. There's going to be no commingling. With shotcrete, that's not true. With shotcrete, you can shoot a pool, half a pool, or come back and add a spa 20 years later, roughen up the surface, have a three-dimensional bond plane, and then shoot your material. And that paste at that high velocity actually penetrates into the pores of the three-dimensional receiving surface and has a commingling or a physical bonding connection. And that's why there's no such thing as a cold joint in shotcrete. And there's also no such thing as a time limit. That what I'm describing and what you asked about is monolithic shooting.
Right.
Shotcrete, the beauty of shotcrete is we can do a subway system in New York City. We can do infrastructure work, repair a bridge going across the Hudson River. We can shoot piles and piers in Grand Central Station that are 70 years old, and we can fire as long as we prep the surface right, as long as we get to an SSD condition, three-dimensional bond plane, good hard material, you can add concrete to that and still be monolithic. So in the swimming pool arena, you always can add, as long as your receiving surface is solid and hard and not deteriorated and is prepped in the right manner, whether it's the day before or the year before,
right,
doesn't matter.
Yeah. So yeah, going to that, like difficult sites. I mean, out here in Southern California, we have a lot of hills we have to deal with. Mm-hmm. So, sometimes we'll doing a negative edge pool, or we have like a surge basin that's just hanging off in the air. Mm-hmm. That's the great thing about shotcrete is I can just shoot a certain portion of that and do proper form work. And then we can, at a certain time, we can go ahead and pull off that form work and continue on with the rest of the pool. Yeah. And that's the great thing about shotcrete is if I want to wait 2 weeks while I cure out, some of the rest of the pool, I can do that, or wait a month, or, whatever. If I had to do more plumbing or, reestablish forms.
Well, any type of vanishing edge, and I always say this when I do the teaching in classes with construction or we do a project profile, I've never, ever shot an entire vanishing edge pool in one day.
Yeah.
You can't, because if you shoot properly and you had all the right steel for your surge tank or your surge trough, or your wear wall, and the forming of the edge, you got to strip that forming and then go back and finish shooting. So we never get to a point where we strip and shoot that same day.
Right.
There's just too much work involved. And if you're shooting a vanishing edge in one day, you probably have a lot of guys in the job, or you're kind of rushing through things where you really shouldn't.
Right. Yeah. We always shoot our weir walls. Second day a couple of weeks later. Typically, what we'll do is we'll shoot the majority of the shell, and then we'll come back and we'll form up the weir wall, and then go ahead and shoot against a good solid form. So, and that's because it just makes that tightness of the shotcrete, that much tighter. When you're shooting against a nice stable form.
Well, forming's key. It should be able to resist the miles per hour of the sprayed material. So think of it this way: your concrete is probably going with the right compressor size, you're shooting it at 60 to 80 miles per hour. Right.
Now, I found a lot of shotcrete contractors, at least in the pool industry, what is they don't typically have the minimum CFM compressor. A lot of times, what is the minimum CFM for a wet mix?
In wet, at the end of the day, you should have at least 250 CFM. That's what ACI 506 recommends. In dry, you should have 650 or above.
Right.
I mean, a 185 compressor in wet is for irrigation. It's not for concrete. So, right. I mean, you can't run a 185, and a lot of guys do it, but the nozzle's got to be so close to the steel. And by the end of the day, filters and just if it's hot out, the compressor's getting tired.
Right.
And you got to keep closing that distance between nozzle and substrate to make sure you're not losing the speed. So I see guys who shoot with a 185, and we do expert witness testimony, and we'll look at all the equipment involved, and there's voids behind some of the bigger steel or some of the cross sections in the corners. And I always ask, well, what size compressor do you use? Well, 185. It's an industry standard. I said, it's not an industry standard. You're not even supposed to use 185.
Right.
You blow out irrigation lines with a 185.
Right.
It's not designed for spraying concrete. You got to increase it. I shoot a 375 Ingersoll Rand compressor for our wet, or we'll get a 400.
Right.
I mean, the velocity is the key.
Right.
And more velocity, the better. If it's too much, you take a step back or you make an adjustment. But you got to have the air. The air is the critical vehicle for proper application, especially if you're doing vanishing, like you're doing vanishing edge, big steel, double cage, double curtain. You got to get the concrete from the front of that steel to the back of that form, and then start building it towards you. You can't all of a sudden just shoot and clump and have the steel be a barrier and have voids behind it, because then you get effervescence, you get surface delamination, tiles coming off, you get leaking. I sat in a class, I don't know how many years ago, and some jackass told me, well, weir walls are somewhat porous and they're supposed to let water through. That's the biggest bunch of crap I've ever heard in my life. You shoot concrete, you shoot in the shotcrete process according to ASA and ACI, your pool shell is supposed to be watertight,
right?
Plus or minus that day's evaporation. And that's your goal.
Right.
You're supposed to be shooting watertight, not waterproof, because nothing's waterproof with infinite pressure and infinite time. There is nothing waterproof. So watertight, the ability to hold concrete,
right?
Like a bird bath.
Yeah. Do you think one reason why the water dampening industry is making it a good toehold in our industry, in the pool industry, is because of lousy shotcrete?
Exactly.
Yeah.
These guys have a job because we stink.
Right.
That's as easy and straight as I can put it. You get guys who promote 2,500 psi concrete, 3,000 psi concrete, voids, effervescence, shoveling rebound, stairs with no steel, cracking, all this kind of stuff that you're not supposed to have according to ACI and ASA, and you get people producing that type of garbage. Well, of course you're going to have a water, this waterproofing industry, this parallel industry, and they're going to follow all the junk around and say we can fix it.
Right.
And then the problem with that, Grant, is you do it so much, the expectation of the end user is that, okay, my concrete is going to need some type of protective layer. Now, all the guys, you and maybe not you, but all the guys in Genesis I've been dealing with, well, you really got to waterproof your shell. I have, in my 30 years, I have put 2 coats of damp proofing or waterproofing on some of our shells in 30 years.
Right.
Because we're shooting 5,000 or 6,000 psi, we're curing it, we're letting proper hydration and strength gain, we're filling the shells full of water. I mean, part of our specification, when we write a specification for a client, is you need a tank test. Councilman Hunsaker does that, and we do that for Drakeley pools. We show the client our pool will hold water before plaster, before tile, before any of that other stuff.
Right.
So the waterproofing layer is not necessary. And as a matter of fact, one of the guys in the ACI told me, the more Band-Aids you put between the finished layer and the concrete, the more chances you're going to have that thing's going to fail at some point.
Right.
Now, I'm a big fan of Shotcrete and Vito Mariano and what he can do for a shell that needs it.
Right.
So I'm not saying not to use waterproofing, but if you do it right, you don't need it.
Right.
These guys better find another industry. If everybody in the pool industry puts concrete down, nobody needs any of that stuff anymore.
Right. No, I tell you. I mean, that's my first thing is like always use it. I mean, Shotcrete's your first line of defense. A good Shotcrete application, you don't need, water dampening products.
Well, I'd give you an example. So I come from a third generation. I have my own company, but I used to work for the family company. So my grandfather used to shoot dry, and they did a pool, one of the first kidney-shaped pools in Connecticut, New England area in 1959. Freeform, not rectangle, not poured, shot with dry. No plaster, just a trowel finish. My company vacuums that pool today.
Wow.
We've done new tile, new coping. It's a concrete surface. It's doesn't lose a drop of water.
Wow.
1959.
Yeah.
And you're talking back then. There wasn't technical data. There wasn't. I mean, they knew water cement ratio, mix design 4-to-1 minimum mix ratio. They knew how to cure. They knew how to place it in shovel rebound anything, and it shows. I mean, you do Shotcrete right. There's no time limit. You can't tell a client, well, the pool's going to last 20 years. You need to renovate it. I can't say that. I have no idea how long it's going to. We take care of pools that are poured concrete back in the 30s, and it's 10,000 psi now.
Right. Yeah. Because it takes a long time for concrete to actually cure out fully.
Well, once all the Portland particles are hydrated with water, you'll reach your ultimate strength. The question is, when's that finished?
Right.
Hoover Dam's not done.
Right.
It's still getting stronger in areas.
Yeah.
So it's nobody knows the answer to that, but we do a pool. I'll tell a client, well, it's going to last longer than you and I are going to be on the planet. I can tell you that.
As the world's leading exhibitions organizer, Informa delivers over 550 international market-leading events annually through face-to-face exhibitions. One of their biggest events is World of Concrete. At World of Concrete, find all of the products, resources, and valuable information necessary to strengthen your business. This is a commercial construction industry's first, largest, and most important annual international event for concrete and masonry professionals across the globe. Sign up today at worldofconcrete.com. This event is fast approaching on February 4th through the 7th, with education the 3rd through the 7th. You do not want to miss this colossal event. Sign up now. I will see you in Vegas at the World of Concrete.
Let's get in backtrack a little bit into curing. We're talking about proper curing. Mm-hmm. Typically what, we'll do is we'll go ahead and, shoot our shell, and then within a couple of hours, we'll get the soaker hoses going around it, keep moisture constantly on it. Mm-hmm. And that's like a key factor, to retaining that moisture in the shell. Can you kind of expound on that a little bit?
So you shoot your concrete and you have mixed water. Okay. The mixed water that you mix your materials, your pozzolans, your sand, your cement, whatever your additives are, water controlling admixture, hydration, reducing, whatever. So that water is in that pumpable material that you shoot. Now, the idea for curing is that it helps strength gain. So what do I mean by strength gain? Well, strength gain means that the water you just mixed everything with has to come in contact with Portland. So if my fist is a piece of Portland, I hit it with hydration, it grows calcium silicates, for lack of better terminology, and these fingers grab and lock onto the surrounding particles, the aggregate, the sand, and this all locks together and it gets hard into a substrate, which is called concrete. The key is that we have to have enough water to hydrate all the particles in the mix. So if you don't cure, when you hydrate, when you get to this point, generates heat. The heat will then evaporate the water if the concrete interior matrix gets too hot. So if you're evaporating more water than you have to hydrate these particles, you won't hydrate all the particles, you won't get ultimate strength gain, your concrete will be weaker. So how do we prevent that? We have to control the temperature of the concrete during hydration. And you do that by curing or putting a moist water coat keep it damp on top of the surface, so the surface of the concrete doesn't get too hot where it starts to turn that water, gets too hot, turns to gas, and evaporates. So the reason you cure is to make sure that the water inside the concrete wall stays inside the concrete wall and does its job of hydration. If you don't cure, I get a lot of calls where, okay, I have the Shotcrete guy shot the pool, come back 24 hours later and there's cracks.
Right.
It's a hotel pool or something like that. I says, well, and the concrete guy said, well, we did everything right. It's not our fault. I said, well, who cured it? And the general contractor says, well, some idiots say, well, it's self-curing. I'm like, no.
Right.
Who put water on the concrete surface to control the heat of the surface, which allows the water inside the mix to stay there and do its job and hydrate? Yeah, the answer is nobody. It's not the Shotcrete guy's problem.
All right.
In today's world of Shotcrete, and I tell this to a lot of general contractors, these guys don't. I'll ask a Shotcrete contractor to guarantee their structural strength, their compressive value. And they said, one guy, I'm getting in an argument with this guy in Washington, D.C. at the Hilton Garden Inn across from the White House. He says, I'm not guaranteeing my concrete, and if you make me, I'm walking. Then he tells me to go F myself. I'm like,
right.
What? I looked at his mix design and said, what's your problem? You got a good mix design. It's easy to get 4,000. He says, I'm not guaranteeing it because we leave the job at the end of the day. And what he just told me in a matter of a few words is, nobody's curing the pool. Nobody's watching it. Nobody's watching strength gain through curing and hydration. He can't be responsible for the end product. All he can be responsible for what he did that day. And he was absolutely right.
Right.
So curing is a huge problem when you subcontract a Shotcrete guy or someone placing dry or wet mix, and they leave in the day, and you as a general contractor, a construction manager, owner of a pool business don't know enough that it's now your responsibility to make sure that concrete gets proper strength gain. And if it doesn't, it's not the guy who shot it's fault. It's your fault.
Right. Yeah, you can't leave it up to the homeowner like a lot of guys do. They'll leave a little note on the back door when they leave and say, hey, hose this down a couple times a day. Walk over plumbing trenches and, and wire and everything and just, water this thing down. So it's not the homeowner's responsibility. It's the pool contractor's.
Yeah, pool contractor can go get some soaker hoses.
Right.
Hook them up to or put a grass sprinkler out there.
Right.
Or like in California, you guys are in a drought, get some burlap.
Burlap, right. Correct.
Put it and just wet it once a day. But you need the concrete to stay in a moist state. 28-day is ACI cure. Minimum 7 to 10 and get your good strength. At least get you going in the right direction.
Yeah. Now I hear a lot of this from the Florida builders. They say it's so humid down there that they don't need to water cure their pools.
Yeah.
Is that true? Not true? What's this?
Not true, Your Honor.
Okay. All right. That's what I figured, but I hear it a lot, so I wanted to kind of clarify it.
If it's raining,
sure,
it's one thing. Or if it's such there's a mist out,
right,
or it's foggy 24/7,
right,
with right temperatures, maybe,
right.
But again, not true, Your Honor.
Okay. Yeah, it's so humid down here. I can barely breathe. Yeah.
Now,
yeah.
What Florida guys and guys in wet areas of the country, the ground is wet.
Right.
So you do have a sense of curing on the backside,
right,
which is great. But the front side is where all the tile goes and the plaster, and so you need to cure the top of the beam and then inside of that pool.
Right. Yeah.
And having groundwater is not really going to help you.
Yeah, no, I gotcha. So, yeah, I mean, and then, a lot of times with the dry mix, what happens is the flashing. I mean, we know it's not good, but explain to everybody why it's not good.
Well, flashing, it depends. You can flash over a pool in a as long as the surface is properly prepped. Okay, and it's still gaining strength and it accepts as part of the overall structural member. But if you flash over a dry mix job and you don't prep the surface properly, and you just kind of just dust it to make a nice cleaning, you don't get a good bond. You don't have commingling in the three-dimensional bond plane. Stuff's coming off.
Yeah.
So just to level out the pool and not understand, did I just create a cold joint?
Right.
Did I not clean the surface? Did I not get the dust off? Did I not hydrate it? Is it not in an SSD condition? So the new concrete over the top of it, will it accept it? Will it be part of the monolithic shot? And if the answer is no, it's coming off.
Right.
So I don't have a problem with people flashing. I have a problem with people not prepping the surface that's receiving the flash.
Right.
Because we do that in the subway tunnels all the time. If we'll East and West Cavern and Grand Central Station, we built it. We had an A line. We had to bring concrete out to an A line, and we got inch plus or minus, a couple 100 feet down, 100 feet high. So you go back over it and you fine tune that with a fine layer of dry mix shotcrete. We flashed that, but the surface was rough. It was wet. It was prepped. It was ready to get. It wasn't dusty and all that crap.
Yeah, talking about a little bit of that prep or that cold joint. I know you need it. Surface saturated dry, SSD. Yeah. Rough surface, three-dimensional plane. Yeah. And there's something else called latenance. What's that exactly?
Well, latenance is a drying technique, a little sheen or almost effervescence on top of the surface that is not cementitious, so it should be chipped off. So any of the concrete gives you back, some of the stuff that comes out of the mix. You got to get it cleaned off and down to the hard concrete. But to have good bondability and have monolithic shooting and get rid of cold joints, you have to allow the receiving part of the concrete be open three-dimensionally and allow that paste penetration to get in there. Microscopically get in there, but it's got to commingle. If it doesn't commingle, if we're going to shoot against this green wall, that's not a three-dimensional bond plane. That's a slick surface that I can't put paste penetration through. So if we start roughening it up and get into a kind of microscopic peaks and valleys, all of a sudden we have a locking mechanism that holds the bond. And that's the whole thing.
Right. Okay, gotcha. Yeah, because people are kind of confused. I know that got brought up one time on the forum a long time ago about some effervescence that had come out and how well to clean it off and everything.
You got to clean it off because it's not part of the cementitious material and it's not going to hold your bond and it's going to be a bond breaker. Right. People ask me, well, should I use bonding agents on concrete? I'm like, no. I said, as a matter of fact, bonding agents in shotcrete construction do the opposite. They guarantee you that you won't have a bond. So you have a three-dimensional bond plane. You have a microscopic peaks and valleys. You put a bonding agent on top of that, and it smooths that rough surface. I don't care what little divots it goes, but it smooths out that rough surface. And now you have nowhere for that paste penetration to go. Right. So you just put a bridge over what you're trying to shoot at.
Right. Yeah.
And that's why you don't use bonding agents in shotcrete.
Right, gotcha. Going back to formwork, I mean, the thickness of the plywood, that has a lot to do with a good sturdy plywood. What do you normally use?
3/4 inch.
3/4 inch.
Rigidity is the key. Right. I don't care what you use. It's got to be rigid. It can't move.
Right.
So you see guys use foam and some of this vibratory materials. That's not proper shotcrete.
Right.
You can shoot against the earth as long as it doesn't move. You can shoot against plywood. You can't shoot against chicken wire. You can't shoot against mesh. You can't shoot against foam. And I listen. I, as a pool builder myself, shotcrete's hard work. It's a long day, and the last thing you want to do is somebody come on, some know-it-all like me, come on and say, "Oh, you can't do this, you can't do that." I mean, just the result of the product varies based off of how well you prep your receiving surface. So the less movement you have, the less voids you have, the less effervescence, the less water penetration. I mean, the idea for the concrete in the marriage of the concrete and steel is to have watertight, no voids. Protect the steel, don't let it oxidize, expand, and cause a crack or a delamination. So forming is key in that. You shoot against something, it should be hard. It should not move.
Right. Yeah. Now, when it comes to it's like spa dam walls. Typically a lot of pools have a spa that's attached to the pool. That dam wall that's in between the pool and the spa. Mm-hmm. If it's hard to form, unless you do 2 shots on that. Typically, a lot of guys aren't going to do a 2-shot process on that type of pool. Mm-hmm. What's the best way for them to actually, get a best shotcrete application on the dam wall? We know it's not just strapping pegboard into the outside, then strip it off, and then, flash it on the other side.
Well, I mean, you can tie a form board to it. I mean,
right.
Plenty of guys use pegboard.
Yeah.
The problem with pegboard is if you get the steel up against your pegboard and you strip it off, you get rebound, you get rock, you get stuff stuck around that steel, and you want to make sure that doesn't happen. So you can do pegboard with a spacer and just consolidate and surround that steel and then pull it off and then flash the other side in a plastic state. That's okay. But the key with the dam walls and the common walls is you got to encapsulate the steel, you got to get your thicknesses, you got to shoot to your wires. You need forming that'll help you do that. I've seen guys take that little chicken wire, that mesh, and put it in there. That's the worst thing you can do. We've done a couple expert witness cases on a vanishing edge wall where they put mesh in between the steel and shot against both sides of the mesh. The problem is that the paste goes through the mesh, the stone hits the mesh and falls to the bottom. So then all of a sudden in this vanishing edge pool, they had a cavity going right up through the middle of that wall from all the rebound.
Right.
So it's, I appreciate the shotcrete guys trying to let's get a form in and out of here quick. Let's make sure we do a good job. And what forming product will help us? You have to be aware that certain forming products will actually hurt you. Pegboard doesn't hurt you if you do it the right way. No, you get some of the Genesis guys say, never use this, never use that. Well, okay, well, you hold the hose for 5 days in a row, 10 hours a day, and then tell me.
Yeah.
But if you just understand what you're trying to get to, good encapsulation, no rebound generation, and good solid material, good bond, do whatever you want to do. But if that's the end result, that's okay. If it's not the end result, take a look at your means and methods, and maybe forming is one of them.
Right. Yeah. Kind of going on to like ACI certified nozzleman. What does it take for a Shotcrete guy to become an ACI certified nozzleman?
So we started pushing this back, 2003, 2004, for the pool industry, and you shoot concrete, and you have 500 hours. You are and you can document where you shot. You are allowed to take a test. You shoot a test panel, you take a written test, and you have a verbal test with an ACI examiner. And as an ACI examiner, I do this a lot in the pool industry to guys who are trying to be certified. And what the certification says is this person is doing it the right way. And it's good for the general contractor. It's good for the homeowner. It's good for the employer, that Shotcrete guy, that he is taking the process seriously and understands what he should and shouldn't do. So we're trying to raise the bar in the Shotcrete industry that says if you get your guy certified, that's a basic driver's license certification. It's not anything high tech. You can shoot this type of substrate, and I think it's good for education, especially for the pool companies, because you go through a certification process and you realize, oh man, I've been doing this wrong forever.
Right.
I did not realize this was the wrong. I've been doing this, I've been doing that, and it's not the right way. So it gets us all on the same page. We have 3 certified nozzlemen. I'm a certified nozzleman as well as an examiner, and we teach the process, and I test for it for the ACI and the ASA, and it's a good process. And let's face it, we didn't go to Harvard in the pool industry. So taking a written test. And that kind of stuff. We'll do a verbal test, for guys who are not great reading. I mean, I did a test in Pittsburgh. The whole crew didn't get past the 6th grade, but they could put Shotcrete anywhere, and they were excellent at it. So just not having the ability to read or write too well, or some of the Spanish kids, some of these guys do terrific concrete, and they know what they know. They just can't verbalize it. So the testing protocol is formatted for the applicant. I mean, you have to know certain things.
Right.
You can verbalize, you can put it in writing, but the certification is a terrific thing for the pool industry because it gets everybody on that basic level of understanding of what this process should and should not do.
Right.
I mean, the pool industry is the biggest abuser of it. These are the guys who should be the most certified and, credentialed.
Right. I mean, when it comes to like the strength of the concrete, I know that matters a lot with water tightness.
Yep.
Why is that?
Density. You're trying to build a product that gets away from permeability and porosity. Okay, permeability and porosity lead to waterproofing, lead to the next industry. And if you want to save money as a subcontractor on your Shotcrete application, well, hire somebody who's awful. Hire a 2,500 psi plan. I mean, you'll save money on cement. There's no question about it.
Right.
But you'll pay for it in the end.
Right.
And the waterproofing guys take all the money because they fix all the crap. So compressive value means density, durability, water tightness, bondability with glass tile, bondability with plaster, bondability with your substrate. So that you get good density, good water tightness, you have a better performing shell. You have a longer lasting, more durable shell, and the things work better around it. I mean, it's a domino effect.
Right. There was a discussion a couple months ago on the Facebook page about the compressive strength, and now you could shoot a 2,500 compressive strength, and if you had your water to cement ratio correct, it would get up to that 4,000 value.
It would have been called 2,500 if your water cement ratio was correct.
Right.
Okay, that's a misnomer. You have correct water cement ratio, your value is not ever going to be 2,500. To get 2,500, you have to order 4,000 psi and wet it up.
Okay.
Or you throw rebound and you screw up. To get less than 4,000, you have to try and screw this up.
Okay.
It's not hard
to
get good compressive value. And if you're in wet mix, you can't pump 2,500 psi.
Right.
I mean, it's you adding water at the nozzle, or you're adding water right at the hopper. I mean, it's awful.
Yes, way too much sand.
Well, I mean, it's
or just
it's
not
segregated.
enough
So
right.
imagine microscopic view of these Portland particles. You add water to weaken the mix. The particles go microscopically away from each other. They grow their calcium silicates. They don't bond. Right. So now they're left in a sample away from each other. The water dries out, and then you do a compressive value and you squeeze that together. There's no consolidation. There's no strength.
Yeah. I mean, with concrete, especially, water kills on it. Like I said, we pour a lot of concrete decks, whether for sub bases or just finished work, and then walls and things like that. And it's the problem I find is the pumpers especially don't, and the concrete driver, they have no understanding about how water works in cement.
Right.
So I've always got to be there whenever, and just standing out there at the pumper, because if I go back onto the job site, lo and behold, all of a sudden I see that drum turning quickly. I'm like, what'd you do? Oh, I added 10 gallons. Yeah. It's like, no, you don't add any water without my permission on it, because that's what's going to cause, especially with finish work, shrinkage cracks.
Sure. Sure. And it's a hot day.
Right.
I mean, I'm a victim of this. We had some ready-mix companies will send 2 trucks at a time. We order our trucks 10 yards an hour apart because I can unload in about an hour.
Yeah.
So we get one concrete truck and another one pulls up. And I'm like, you just were loaded right after this guy. He goes, yeah, at lunchtime. I said, get out of here.
Right.
Send me something else. I didn't watch the guy coming back. He went down at the bottom of the driveway, which is probably a quarter of a mile at this weekend house, sat there, then come back up.
Right.
And I wasn't there. We had a shrinkage crack between his load and the load before him. And the owner says to me, he says, I thought you were concrete Jesus. What the hell is this? And I'm like, I don't know, but I'll find out.
Yeah.
I took a look at the guy's ticket. He didn't go back. He just went down and sat in the driveway for an hour, added water and spun it. And he came back. His water cement ratio was way off. We were so busy humping material, we didn't check the ticket. We just took the ticket, signed, and threw it in the truck. So, shame on us for not paying attention to details, but your point's well taken. You need to be a good foreman and watch. If you're doing ready mix, a lot of the times, so we'll order our concrete mixture with 5 to 8 gallons held back. So we have the ability to add 5 or 8 gallons on the job site when it's hot, and still within our water cement ratio. Yeah. We never have the truck fully loaded with water leaving the plant because you never know what's going to happen.
Right. And that is one nice thing about the ready mix plants here is they do hold back the water, and they actually put on the ticket the allowable water, that you can add to the truck to get it up to, say, a 4-inch slump, or, for pouring a deck, or, wall footer or something like that. Right. So if people pay attention to that ticket, or at least their mix design, I think that, really cut down on all the problems that you see.
It's tough. Grant, it's tough. You do this type of work. Nothing's ever going to go 100% the right way.
Yeah.
Every job I've ever done, there's something, now what? Yeah. And you got to adjust. But as long as you're a quality contractor and you do the right thing and you understand the process, you keep yourself out of trouble.
Yeah, right. Yeah, going back to form work and difficult sites, because that's what we really want to get into. What's probably the most difficult site you ever did, and how many shots did you have to get? How many shots did you have to do on that site to get the thing, at least a shell, completed?
Most difficult site we've ever done. Well, we've done 2 down on the shore, in Greenwich, Fairfield County, Connecticut, Greenwich, Connecticut. One was a yacht club, 82 meters swimming competition with a 15-foot diving well. That the pool sat on top of 65 steel piles, 60 feet long, driven down into refusal, and then the pool floor was 3 kgs, the number 7 bar, which we pumped, and then had very steep slopes, and then we shot the walls on top of the pool, fighting the tide of Long Island Sound in the middle of the winter.
Right.
That was pretty hard. But it worked out well, and we do that when we do a commercial pool. Half of our work is commercial venues. We usually pump the floor, cast the floor. Same durability, same compressive value, and we'll roughen up the joint between the wall and the floor, and we'll shoot that joint.
Right.
And that's how we do our commercial work. And it's monolithic. As long as you're shooting onto a concrete receiving substrate, it's still monolithic.
Right. Yeah. Now there's we were talking a little bit about water dampening products. There's integral mixes you can add onto a product. So if somebody gets spec'd out, they're working for an architect or an engineer or GC, and they spec out an integral waterproofing. Is there anything the contractor would have to look for when they're doing? I mean, obviously the mix design has to be right. The appropriate amount of admixture has to be put into the mix. Have you dealt with that before?
Well, we've taken on specifications where they ask for it, and I've always taken it out of this mix. internal waterproofer assumes you're not going to do something right.
Right.
You have the right mix design and white cement chemistry. You don't need that.
Yeah.
Matter of fact, I think it gets in the way.
Yeah.
You have mixed design, and I understand it's microscopic, and there's a lot of good guys who sell this stuff, but just focus on proper shotcrete. If you get your compressive values and you get good spray and you don't need this stuff.
Right.
So I've never used it. Actually, I take that back. I have used it just based on one of the manufacturers asked us to use their product, and it, the theory is correct where it's microscopic spikes and it kind of breaks up all the clumpiness and it makes hydration and the whole process work together quicker, more evenly.
Right.
But I've never had a need because we stick with the ACI specifications.
Right. So going back to like the application of it, why do the nozzlemen twist the nozzle around in a circle?
Wrap it?
Yeah.
Just because you want to make sure that you get your concrete around that cross section of steel. So you like to wrap it in a rotating manner just to make sure that you're covering and getting good consolidation around your steel, especially in heavy congested areas or cross sections.
Right. Okay, great. Now, there's a lot about splicing. I mean, what's your thought on no contact versus contact?
Well, whoever came up with the idea of non-contact lap splicing never shot a nozzle and never shot a floor. So if you take a look at, you're standing in a commercial floor and you have non-contact lap splice, you're standing on the floor and you're looking down at the shot. You have bars that look like go forever. You look like you got a floor, a curtain of steel. And what it does as you shoot the floor is it increases rebound. You get more material bouncing off because the angle that you're shooting on, even though it's a 90-degree angle, as it's facing you, you're going through all this steel one after another. So I think non-contact lap splicing was designed by somebody who never shot a pool. I understand the reason why. Some guys put bars side by side, big thick bars, and they get a void behind it because the nozzle is not wrapping and rotating. But if you carry your steel in a contact lap splice, front to back, you're not going to have that problem. Yeah. It's all about application and the ability of the nozzleman.
Right.
But non-contact lap splicing exposes a hell of a lot more steel, especially on the floor, that you have to shoot around and increases rebound.
Yeah.
So I'm not a fan of it, and that's why.
Okay. No. I mean, that's a good explanation for it. So, yeah.
Well, it's my explanation.
Explanation for it. So.
I'm not calling all engineers dumb, just some of them, okay?
Gotcha. Well, talking about like the process of shotcrete, one of the things is deputy inspectors. When I tell a client, hey, we're going to have a deputy inspection on the job site today, they think it's from the city, but it's a company that is hired independently to come and actually, test or do a test panel and test the shotcrete. Right. And there is a certain PSI that once you go above that PSI, you need a deputy inspector. Can you kind of elaborate on that?
Yeah, it's.
I do one on sometimes these wall footers, anything, because it's like it kind of backs up, what I'm specing on the job.
Just your concrete's going to be a certain compressive value, and I've heard this before. This is out in California.
Yeah.
So if your concrete's going to be somewhat strong, you need someone to inspect it. But if you're going to give the client, garbage,
right.
Don't worry about the inspector. We're just going to give you crap, and we don't need to look at it.
Right.
That's essentially what that means.
Yeah.
It's the dumbest thing I've ever heard in my life.
Right.
If you do concrete right and you stick to the minimum values
right.
specified as code by the American Concrete Institute, the American Concrete Institute says that any concrete exposed to water, surrounding steel in different exposure conditions, is a minimum of 4,000 psi. That's been around a long time.
Right.
Okay. The pool industry and their subsequent inspection process has taken that and bastardized it so bad that, look, Mr. and Mrs. Smith, you're going to get a great home, but I'm only going to shoot 2,500 PSI, so we don't even want to watch it. We're just going to give you junk, and here you go. Congratulations.
Right.
Live it and love it. That's so stupid.
So once again, because everybody's raced down to the bottom, somebody came up with an idea to say, because a lot of cities out here, they mandate it, that you need to have a deputy inspector on site whenever you're shooting, shotcrete or concrete pouring.
I think that's a good idea.
Yeah, right.
We shoot as an examiner and someone who teaches the process. I'm not necessarily going to have a special inspector, but if I'll do a commercial application, we'll get a third-party inspector or a lab or someone who does this type of work, take cylinders, we'll shoot panels, they'll take cores, and we'll just verify what we've said to the end user. We did a commercial high school pool, Canterbury High School in New Milford, and it was supposed to be a cast in place because they did not want the shot process.
Right.
They heard terrible things about it. the engineer specified. And I said, well, we're gonna shoot it, and we're gonna get those values. And they're like, well, we're not gonna accept it. I said, I'll tell you what. I said, if I don't get your values or exceed them, I'll rip the entire pool out and do it your way, and I guarantee it.
Right.
And by that time, I said, okay, fine, we'll take your guarantee. So I had to make sure.
Right.
And I'm thinking to myself, God, this is easy. They
Yeah.
specified 4,000 psi. We had 6,000 psi in 21 days.
Right.
You know, we broke at 120 days at 7,500. So
Yeah.
when we get to that point, and you show the end user and you show the engineers, this is what Shotcrete actually can do. Then they stop questioning you.
Right.
Then they say, okay, here's a guy, or here's a company, or here's a organization that understands concrete science. We're going to leave him alone. We're going to worry about the other guy in the job site or somebody else.
Right.
But having a deputy inspector or a special inspector to verify third party is a great idea. And I think, California is a funny little animal here.
Right.
It has a crazy rules. If you just follow the ACI,
right,
everybody'd be a lot better off.
Yeah. Right. I mean, should the Shotcrete company hire the deputy, or the contractor, or the homeowner?
Well, if I'm a pool company,
Yeah.
My sales pitch to the owner is I'm going to have someone verifying what we say.
Right.
Until you do it enough that everyone knows that this guy is on the level and knows what he's doing.
Yeah.
I don't, having more oversight
Right.
is a waste of time. It's a waste of time for me.
Right.
But if you're not going to do it right, and you're not the quality company, then oversight's important.
Yeah. Right. Going back to kind of like the application of Shotcrete, I think there's a big misunderstanding about it. How can people contractors that are out there, obviously we have the Genesis courses, we do stuff like this, we do like smaller classes at some of the trade shows. How can somebody find out how, we were talking about this earlier today, how can somebody find out, these are the minimum values? Where do they go to find that? And
go to the American Shotcrete Association, shotcrete.org. There's a 7-position statement letter, 7 position papers we've written for the pool industry as a reference and a resource to keep contractors out of trouble. Minimum compressive values, monolithic shooting, sustainability, terminology, forming. We have a new curing paper coming out. So anything that you kind of the essentials for pool concrete installation come out of the American Shotcrete Association. The other resource, which is going to be even bigger and more important, is the American Concrete Institute has a pool shotcrete committee, 506OH, which I'm chairing, and we're going to put out a pool shotcrete document from the ACI, which will be legal and binding.
Right. Great.
You get in trouble, and the attorney's going to grab this book and put it on a witness stand. Did you follow these?
Right. Yeah.
These rules, yes or no?
Right.
And if you can't say yes, then you're in trouble.
Right. That'll clarify a lot of things.
Hell yeah.
It's going to be great. I can't wait for that to happen.
Yep.
So, well, Bill, it's great to have you here. Concrete's one of my favorite subjects. We work a lot. I mean, there's not a day that goes by that my pickup doesn't have some kind of form of concrete in it. And so really enjoyed having you here.
I appreciate you letting me sugarcoat everything.
Thanks, Bill.
All right.
Ask the Masters is dedicated to educating, mentoring, and designing a better workplace for the swimming pool industry and their families. Please take a moment to share, like, and review our content with all of those that would be interested.